Assalamu alaikum friends. Welcome to day 6 of Performance Management 15 days revision crash course. The topic today is planning with limiting factor. In the previous day, day 5, we discussed about cost volume. Under that we went through budgeting, break even point, then we went through some charts describing total cost, fixed cost, contribution, margin of safety. So here we are going to go through limiting factor. Now we are going to focus the limiting factor analysis and linear programming. Limiting factor, as the word says, factors are limited. Your factors are limited. They are short in supply. Okay, they are short in supply to the extent that your sales demand cannot be met with whatever factor you have. It could be your human resource, it could be machineries that you have, it could be your labor hour, anything, any factor short in supply is known as limiting factor. Okay, so under this situation, you need to find out, okay, your objective is to maximize the contribution per unit of limiting factor. That means from that limiting factor, what is the maximum contribution you can achieve? Contribution I've explained in day 5 when we started with budget and all. Okay, break even analysis. So contribution means your sales minus your variable cost. We do not take the fixed cost into the account. Okay, it is known as contribution. We try to maximize it. There are 5 steps to do this, and in your exam, performance management exam, if limiting factor is given, you should know this 5 step in the order. Calculations has to be done in this topic. Okay, first step, you have to identify the limiting factor. It could be a labor, it could be material, or it could be machine hours. Step 2, contribution per unit of limiting factor. 3, rank the product according to the contribution. Highest contribution is ranked first. Step 4, calculate the optimum production plan. Why do we do this ranking product and all? Because when your factors are limited, it's not possible for you to produce all the product. You can only produce or you can only undertake certain projects which gives you the maximum contribution. That's why. What's the optimum that you can do? You have to calculate that. And step 5, if question asks you to calculate profit, you calculate, otherwise till step 4 you can stop. Now we are moving on to linear programming. We have to use it to find our optimum production plan. Linear programming, what is it? Very important topic for your performance management. Okay, your examiner wants you to have a very good knowledge on this, okay, in step-by-step approach. So you should be able to explain the meaning and carry out calculations. For shadow price and slack, what is this shadow price and slack? We are going to discover it in a bit. Linear programming is used to establish an optimum product mix when there are 2 or more resource constraint. It's not one. Sometimes you might have more than one limited factor. Okay. So this mix will achieve a certain given objective. Now your objective could be to maximize contribution, or sometimes it is to maximize cost, but on occasion. Now define variables. First is define variables. This is the first one. Let x, okay, you have to define variables. Linear programming is basically you are setting an equation. Okay, so let x the number of tables made each month. Define objective. Objective is to maximize contribution. Okay, so let's say there are 2 products, x and y. Set out constraints. Non-negativity, because anything above 0 is non-negativity. It could be equal to or greater than 0, both x and y. And others. So this is already, it's just an example. Okay, Don't ask me why it is 5x plus 2y. You don't have to memorize it. It could be any number. We'll do calculations on this when we do questions on this area. So you can see 5x plus 2y less or greater than 20. Now, step 4. Draw graph showing constraints and identify the feasible region. So for here you have to get endpoints of the constraint line. So just make 1 0. For example, this is like your maths. You are solving a maths equation where you are putting one variable as 0 and finding the other variable. So if you put y as 0, x will be 4. And if you put x as 0, y will be 10. So 4 0 and 0 10 are the points. After having the endpoint, you can draw a line. Using this endpoint, draw the line. Then feasible region. What is the meaning of feasible region? Feasible region in your graph means any line, okay, below a line if constant is less or equal to a certain number, and above the line if greater or equal to. So depending on the sign, if it says greater or equal to, above the line is the region, less or equal to, below the line is the region. Now number 5, solve the optimal production plan. So you need to draw an example in the contribution line by making up a suitable value of C. Remember the equation? It was C plus 5x plus 2y, something like that. Move this out away from the origin to identify the optimal point. It should be the last point you get to that it is still feasible. The last point you can get in that region until it is feasible, because once it goes beyond that point, it might become not feasible. If it's not feasible, it cannot be your optimal point. Maybe right now you are not able to understand this, okay, but when we do questions on this, you'll be able to understand better. But if you have done questions, see, this is the advantage of having revision. You come to know your own weaknesses, right? If you have done a very thorough revision, you know what I'm saying. 5.5 you will be able to visualize. But someone who has not done revision, questions from revision kit will not be able to understand this point 5. Will be very difficult. In case if you are a student like that, go back to your revision kit, pick up questions from linear programming, do all the 5 steps until you don't come to step 5. Then you will understand what we are talking about. Okay, now if the objective, I'm sorry, the last point I told maximize cost, right? I'm sorry, it should be minimize. I think I told maximize. If the objective is to minimize cost, then the line will need to be moved towards the origin. Why towards the origin? Origin is 0. I mean, it should be closer to that now. Minimize will be less. If it's to maximize contribution, it will be further away from that origin. Now, you can determine the optimal solution exactly by solving simultaneous equation of the two lines that crosses the optimal point identified on the graph. So here you have to set up two equations. Okay, you can set up one or both equations until they have the same number of y or x. Look at the difference between the two adjusted equations and solve for x or y. I'm sure you know how to solve simultaneous equation, right? If you don't, you can Google it or take a class from someone, because it was explained in your maths class, right? So I'm not going to teach here and explain you the maths behind it. Okay, you should be able to solve simultaneous equations. Okay, then once you adjust the two equations, now substitute the value of x. So you substitute the value of x and find y, or substitute the value of y and find x. Okay, solve x or y for x. If you solve one, you will get the other one. The other one is the balance. Then answer the question. So it is like solving maths equation, math simultaneous equations, right? Then either minimum cost or maximum contribution, calculate. Write a recommendation to management. Sometimes you should be able to recommend to management also that this products you have to make, this product they should not make, like that. Okay. Now, step 5 can be replaced with the following. Okay. You can determine the coordinates of each of the corner of the feasible region using simultaneous equations also. Then For each of the corner, calculate contribution and select the corner with the highest contribution. What is slag? Slag is the amount by which resource is underutilized. You have not utilized the resource up to its optimum capacity. That is the meaning of slag. Usually it occurs when the optimum point does not fall on the given resource line, because resource has been underutilized. No? So when it's underutilized, you will not reach the optimum point in that line because there's a slag, which is not good. Assumption. Now, for this model that we are using linear programming and all to find maximum contribution, you should know, because this is a model, every model has some assumptions, but reality is something else. Okay, because of these assumptions only we are using it. There are limitations of it. First assumption: a single quantifiable objective exists. What is it? To maximize contribution. Second, each product always uses the same quantity of scarce resource per unit. Is it possible? No, not in reality. Contribution per unit is constant. It never is. Products are independent. You sell A, not B. But what if you want to sell both the product? Right? We assume that we are only selling one product and not the other. Scenario is short term. Now come to the reality. Reality is total opposite of assumption. Multiple objectives could be there. Your objective might also be to take care of risk and return. Also, learning effect. What is the meaning of learning effect? See, as long as you keep doing something, repeating something, right, through your experience and all, you will be able to achieve after a certain period of time that task faster, which took a lot of time for you to uh, do during first time. So first time when you're doing something, it takes a lot of time. When you go along with the time, the more and more time you take, and more you keep repeating something, that same thing over and over again, through experience you'll be able to achieve that thing faster. You will take less time to do the same task later on. It takes some years. So that is known as learning effect, the effect of learning something. Okay. So even though resources limited, let's say labor hours. Okay. Now within short labor hours you can complete. That is, but you need more labor hours, right? That's a limiting this. But as you learn, keep learning, that might not be a restriction anymore. That might not be a constraint anymore. Maybe that factor might not be limited anymore after a certain period of time due to learning effect. That's a reality. But that model does not take that into account. It's based on assumption, no. Third, selling price may have to be lowered to sell more. In reality, it is like that. Discounts as the quantity of material needed increases. Then economies of scale. What is economies of scale? Where your cost per unit increases with the increase in volume. The more volume you produce, your cost reduces because that cost is spread over a huge volume quantity. So you achieve economies of scale. That means you become cost productive, cost efficient, cost effective. You can make the same amount of good at a lower cost, but volume needs to be higher for it. That is known as economies of scale. Customers may expect to buy both products together sometimes. Yes, you might say that, okay, according to limiting factor, optimal solution would be to make product A and not B. But customers might want both the products. Products may be manufactured jointly together. So your linear programming does not take that into account. And in the long term, constraints can be changed also. Fixed cost should be included. Currently, we are not including fixed cost, but it should be included. Okay. And long term, constraints might no longer be a constraint, because when you are given long term, you can hire more laborers. So labor hour could be increased. You can hire more machine. Right? Now, shadow or dual prices. What is shadow prices? The word shadow tells you it is a something extra, right? So shadow price of a resource is the increase in value, usually extra contribution that would result from having one extra unit of a limiting resource. That is the meaning of shadow price. It therefore represents the maximum premium over the normal cost that a firm should be willing to pay for that one extra unit of each constraint. So non-critical constraint will have zero shadow price or slake exist already. As slake exists already. Because whenever slake is there, you cannot have a shadow price. Because shadow price is what? Shadow price of a resource is increase in value using usually extra contribution. But when you're having a slake, when your resources are underutilized, how can you have an increase in value from extra contribution? So shadow price is zero when slake is there. Now, the simplest way to calculate shadow price for critical constraint, those which are very important constraints, okay, limiting factor, very critical, is as follows. Step 1, and you need to remember the steps, okay? Add 1 unit to the constraint concern while leaving the other critical constraints unchanged. One variable only changing. Step 2. Solve the revised simultaneous equation to derive a new optimal solution. 3. Calculate the revised optimal contribution. The increase is the shadow price for the constant under consideration. You have already calculated your contribution before, right? Now to that, add one more constraint and again calculate. Again derive a new solution. So compare the previous solution with the new one after adding that one new unit to the constraint. The difference is the shadow price. Okay. Now, from your exam focus, these are the questions from your revision kit. So we are done with day 6. From your objective case question, that is section B, we have Caraco, home electrics, and from constructed response we have cosmetic company, cut and stitch, CSC company. Thank you for watching, and I shall see you in day 7 of the PM revision crash course. Make sure that you are making the maximum use of this revision crash course, but also you should be doing questions from your revision kit. You should be able to finish the PM syllabus. You should be able to have a very good understanding of the syllabus. Okay, just having the revision crash course without any foundation to performance management, without going through the text, without doing the revision kit questions is not going to solve any of your doubt, nor is going to help you towards achieving good marks in your exam. So make sure you do that as well. Thank you for watching, and don't forget to subscribe to my channel so that you get the latest notification of all my latest videos updates. Thank you.